we're going to continue talking about probability. So, in this lesson, we're going to look at the probability of two events happening, and but these events are called independent. So, this is where the outcome of one event doesn't determine the outcome of the second event. So, if you have a coin and a dice, or if you have you're going to flip a card and flip a coin or whatever it is. So the probabilities of those don't depend. I mean, if you flip a coin and roll a dice, what the coin does doesn't have anything to do with the dice. So that's this first one. The next one we do, it will depend on what the first outcome is. But this one doesn't depend on that. So what we're going to do, we're going to multiply the two probabilities. So the probability of A and B happening, that's this first little bit, is the desired outcome of A divided by the total outcomes for A. So it's kind of like separate. And then we have the desired outcome for B divided by the total outcomes for B. So those are going to be, and basically the probability of B. So it's the probability of A times the probability of B. So it might even be a not situation where we have to do one minus or count up all the ones that are not. So it just depends on how you want to work that out. So let's look at this. Our first example, we have a fair six-sided number cube is rolled, so just one, and a card is drawn from a deck of cards. So you'll need to know some information about a deck of cards. Well, there are um 13 from each suit. So you have hearts, diamonds, spades, and clubs. Those four there. And then you have different names for those, and or one for each one for each. There's one ace on each suit. There's one, two for each suit and whatnot in a deck of cards. So just make sure you kind of are familiar with that. Just a quick rundown. We'll do some more with that later. So we're going to look at the probability of rolling a five and then drawing a jack from the deck. So it's just like shuffled and it's at random or picking a jack. So we're going to take the probability of rolling a five and multiply by the probability of picking a jack. So the probability of a five and is going to be one out of six. So there's one five on the six-sided number cube. And then times the probability of a jack, which is 4 out of 52. So you could do some cross reducing here, or you can actually even reduce the 4 over 52. But you don't necessarily have to. You can just multiply top times top and bottom times bottom. And so what we get here is 4 over 312. And then just dividing that gives me 0.01 or 1%. So that's what we have going on there. So on the next example, we have the probability of rolling an even number, which is pretty significant, times the probability of picking a club. Again, pretty significant there as well. So the probability, someone come over here and write this. So the probability of an even number is 3 over 6 or 1/2. It's a little bit easier if you can start reducing that, but if you can't, that's okay. So if 3 6 times the probability of a club, there are 13 clubs in a deck of 52 cards. So 13 clubs divided by 52 total cards, total outcome. And then I multiply top times top and bottom times bottom, and I get 39 over 312. And then I can divide those two. I get a decimal of 0.13 or 13% there. And then the last one is the probability of rolling an odd number, which is again pretty significant, and drawing not a spade. So we have the probability of odd times the probability of not a spade. Okay, so I'm gonna work this one out underneath because I didn't leave enough room apparently. All right, so the probability of an odd, rolling an odd number with the number cube is 3 out of 6 times the probability of not rolling a spade is, so there's a couple ways you can do this. You can do 1 minus 13 over 32 over 52, excuse me, or you can do 52 minus 13. That would be the spades, taking those out. The rest of them would not be a spade. So that's 39 over 52. Either way works. Um, and then multiply top times top and bottom times bottom, you get 117 over 312. Now, again, you can reduce this, but you don't have to. It ends up being 0.38 or 38%. All right, so 117 over 312 doesn't really tell me much. It tells me it's about a third, but I like that you can see when you see the percent, you can just see it a little bit better and know the likelihood of that happening, which is what probability is all about. All right, on the next ones are not nearly as long, I don't think. The next one is a coin is flipped and a spinner it with a spinner. Okay, with the colors of blue, green, yellow, and red, and those are going to be all equal amounts. So we're going to look and find the probability of flipping the coin and landing on heads, and then spinning a spinner. So those two don't have anything to do with each other. So that's why they're called independent um, events there. So I'm going to find the probability that that I flip heads with my coin, and the probability that I spin the spinner and get a yellow. So that's going to be the probability of flipping a heads is 1 out of 2, and then the spinning the spinner and landing on yellow is 1 out of 4. Top times top, bottom times bottom, 1/8, which ends up being 0.13 or 13%. Okay, so the likelihood of that happening is pretty small still. You wouldn't think it would be, but it is. On the next one, we have the probability of tails and not green. So I'm going to find the probability of flipping a tail with the coin, and then the probability of not green on the spinner. And I'm going to multiply those two. So I have the probability of tails is 1/2 times the probability of not green. So not green is all the ones but green, which is going to be 3 over 4. Top times top and bottom times bottom still. And so we have 0.38 or 38%. So a little bit more likely to flip tails and not land on green. All right, let's look at example 3 here. We have a marble from a bag that has 3 blue, 2 green, and 7 red. And a letter is selected from the alphabet. So this goes back to 9.1 when we talked about the alphabet. So we are going to try to find the probability of green and a vowel. So I want to take the probability that the marble that I draw is green times the probability that I randomly select a vowel from the alphabet. And so that's there are 2 green out of 12 total marbles, and then times there are 5 vowels. We didn't count Y, so 5 out of 26. And then whenever you multiply, you get 10 out of 312. And then dividing that, you get 0.03 or 3%. So very small chance of getting green and a vowel. Now let's look at the probability of drawing or selecting a red marble and a letter before P. So I'm going to find the probability of selecting a red marble times the probability, it's supposed to be a capital P, of a letter before P. So that is going to be the probability of red is there's 7 red out of 12 total marbles times the probability of a letter before P. There are 15 letters before P. So that's 15 out of 26. So then I will multiply through and I get 105 divided by 312. And that is 0.34 or 34%. Okay, on the last example here, we are going to have a random number generator. So these things have just some sort of algorithm where they just pick random numbers. You can tell them to pick a number and repeat it, or don't repeat it, but but they just randomly pick a number. That's all a random number generator is. And then you are going to flip a coin. And we're going to find the probability that the random number generator selects an even number and that the coin lands on tails. So I'm going to find the probability of an even number times the probability of a flipping a coin and landing on tails. So the probability that you have an even number is 2, 4, 6, 8, and 10. So 10 is included in there. So it's going to be 5 out of 10 times the probability of a tail is 1/2. Multiply here, you get 5/20ths, which is 0.25 or 25%. So you have a fourth of a chance to make that happen. If you reduce the 5/10 to 1/2, you could just end up with 1/4, and then you know it's 0.25, and that's 25%. That's what makes making like that's where reducing kind of helps out. All right, so independent events, they do not rely on the previous event to occur it does not affect the outcome. And you are going to multiply the two probabilities together for independent probability, or anytime you have multiple events going on and you're trying to find the probability of that happening. So that's it for independent probability. And now it is your turn to practice with your skill check.